Okay, let's do a quick review before I start on today's notes. Trigonometry is probably one of the oldest disciplines of math that I've ever heard of. And I think a lot of it can be traced to early mathematicians trying to understand how our universe works. You guys have probably heard stories about how people thought the Earth was flat and how they thought that the Earth was actually the center of the universe and the sun went around the Earth. Mathematicians, more so than even scientists, have actually known that the Earth was round for well before like Christopher Columbus thought that they were going to fall off the edge of the Earth and then went to the New World. There's actually I'm getting off track, but you should know this. This is cool. I like it. There's actually a really famous story about a couple mathematicians where they thought the Earth was flat, or they thought the Earth was round, and so they were trying to like figure out which one it was going to be. And I don't remember exactly the story how it works, but the idea is one guy went to a location and he built a tower, and the sun, based on the shadow, made an angle, and the person was then able to measure the length of the shadow. Does that make sense? Well, another person went to another location. Now, I mean, they went far away. Now, I don't know how far it was, like probably 100 kilometers, which, I mean, for us is like a short drive, right? But I'm thinking back, like, at 500 BC, it probably was a long ways. And somehow they found a way to synchronize it, because at the exact same time, the other guy built his tower. Same height, same sort of thing. And what happens is the sun was supposed to cast a shadow. Now, I drew this picture very poorly, obviously. If the Earth was flat, based on where the sun is, I mean, granted, the sun is really far away, but the idea would be that doing that, the angle you'd get should be basically the exact same if the Earth is flat. Does that make sense? But if the Earth is round and there's more of a curvature, then this distance for this shadow and this distance for this shadow would be different. And based on that sort of math, early mathematicians knew this long ago. Does that make sense? So, anyways, that's actually really not the point of what I wanted to talk about. I just put it to mind. So, you guys ever heard that before? Okay. The point I wanted to make is that they've been talking about trigonometry for centuries. Most of it, I think, has to do with how the Earth and the sun relate to each other. I've already mentioned the idea that like going around the Earth going around the sun kind of makes a circle. Circles are really like the basis of trigonometry. I'm just gonna make some more room, I guess. If you can imagine that, again, this is kind of our world. The sun, I know the sun doesn't actually move, but the sun kind of appears to go around us in a circle, which is why we start over here at 0 degrees, which is basically due east. And where it sets over here in the west, we make that 180 degrees. Degrees, however, are kind of a poor unit of measurement. I mean, I think it makes sense when you talk about degrees when you're talking like little kids in grade 3 or 4, because if I ask you like what 90 degrees is, you all know, and I think instinctively 90 degrees is this, right? But 90 degrees may not be the best number, because, I mean, why 90? Why did we pick 360 to be the number? I mean, it's just a randomly chosen number. I've heard before that they picked it because that's how long it took the Earth to go around the sun, roughly. But maybe a better way of measuring things is based on radians. And the definition of a radian is the angle is an arc length over a radius. There's that perfect piece of pizza kind of concept. Long story short, I also need you guys to know that this is like half of pi. This is pi. This is 1.5 pi. And all the way around the circle is 2 pi. Does that ring some bells? You guys remember that? Okay. In doing trigonometry then, what ends up happening is you often get more than one answer. When we actually started graphing sine and cosine, sine looks like this. If I were to ask you where sine of theta equals 1/2, 1/2 is like right about here. Not only is there more than one answer, there's an infinite number of answers. Because it's equal to 1/2 right here, and right here, and here, and here, and here, and here. And you can keep doing that for forever. Does that make sense? Basically, every time you pick up another answer, it's because you've gone around the whole circle, another rotation, and you could just keep doing that infinitely, right? So, another skill that kind of goes along with this then is the cast rule, C-A-S-T. If I ask you where sine of theta is positive 1/2, you should get an answer in this quadrant because A stands for all, and you should get an answer in this quadrant. And you can kind of sketch out real quickly. This would be the opposite, the hypotenuse, opposite hypotenuse. Hopefully you'd know that that's root 3. You'd make that one negative. And then hopefully you recognize this triangle and you kind of know what angle goes in the corner there. Make sense? Basically my goal today then is to take some of these skills that we worked on and just put them all together in another lesson. So I'm not sure that there's actually that much that's new today. Holy smokes, there's a lot to get through here. But most of my lesson is really just a lot of examples. Just going to example you to death. So I need your guys' help. Whenever I start becoming quite redundant and I'm like, you guys have got this, can you let me know? So I'll make sure I ask whether or not you feel comfortable here. So, okay, before I get to that, let's just do my quick summary slides to begin with. Whenever you want to try to solve something, you could basically make a function where you've got like y equals and then you've got an equation. Usually what ends up happening is when you solve, you get one number. Like for example, if I were to give you y equals 3x, and I told you x was 1, 3 times 1 will give you 3. You get one answer. If I were to say y equals 2 to the x, and I tell you that x is 5, you get one number. Well, when you do something like this, there are some twists. I just showed you a second there. Sometimes when you're solving, you can get many answers. So here's the first type of solving. Let's say that I give you the angle. When solving, given an angle. Let's spell angle right. If I give you the angle, there is only one answer. If I ask you for, like, say, sine of 30 degrees, this means, okay, well, plot where 30 degrees would be. So it would be like right about here. There is only one answer. The answer is whatever the opposite and the hypotenuse of this triangle happen to be. Does that make sense? And maybe you recognize this triangle and say, okay, well, if this is a 30-degree triangle, then let's see, that's a 60, that makes that a 1, that's a 2, that's a root 3. So if sine of 30 is opposite over hypotenuse, this should be 1/2. This one's pretty easy to check. You literally just take your calculator and check. Sine of 30. Yeah, that wasn't 1/2. Why? Yeah, good question to ask yourself. I was in radians. So let's redo that again now. Now let's redo it again. And there we go, it was 1/2. Does that make sense? When doing this, you get one answer. Okay. One piece of advice I'd give, if I were to ask you for something like the secant of 19 pi over 6, this was actually a question on your previous assignment there. Don't try to make it the cosine of 6 over 19 pi. Do not flip the angle upside down. What you're supposed to do is flip whatever the ratio is upside down. So if cosine is supposed to be adjacent over hypotenuse, you just want the hypotenuse over the adjacent. So don't flip the angle upside down. Let's do like maybe just 2 of these examples maybe then. So let's say I ask you for the exact value of sine 300. The first question you should ask yourself then is, where does that angle lie? Like, which quadrant does it lie in? So whereabouts is 300 going to be? Fourth quadrant. Sure, fourth quadrant. So somewhere down about here. What is this reference angle going to be? Okay, 60. The reason for that is that 300 is all the way around here. So 60 must be the remaining part until you add up to 360. So, 60 is one of the triangles you're expected to know. So the hypotenuse is always 2. That's the angle is 30. That's the 1. That's the root 3. I don't care how you memorize that. Just memorize it, I guess. Don't forget that's negative root 3 though, because it's going downwards. So, what is sine supposed to be equivalent to? Opposite over hypotenuse. So your opposite is going to be negative root 3, and your hypotenuse will be 2. That is what sine of 300 should equal. You can check your work. Type in the sine of 300. Gives you that number. There's no way your calculator can take this number and convert it into like this irrational number, but you could take negative root 3 divided by 2 and just to confirm that both of these decimal numbers are the same as each other, just to check your work. Does that make sense? Okay. Let's try D. Let's try the secant one. For this secant one, first we got to figure out where is 11 pi over 6 going to be. So this is probably the most challenging thing for kids at first, but I feel like you guys are getting pretty good at being able to recognize how fractions work. If this is 0 and this is pi, then you'd have 1 6, 2 6, 3 6, 4 6, 5 6, 6 sixths. That was pretty bad. 7, 8, 9, 10, 11. Yeah, it actually just happens that it's also in the fourth quadrant again. This one's a little bit different though. This time, this little remaining triangle is the remaining sixth of pi, which is another triangle that you're expected to know, right? So a sixth of pi is 30 degrees. So that makes this one 1. That one's 2. That one's root 3. It's almost the exact same triangle as the one we just drew, except the 1 and the root 3 are backwards. Don't do this. Don't type in the cosine of 6 over 11 pi. Why is that not right? That's the right word to use.
Around the ratio.
Yeah, you gotta flip around your angle, not your, no, you flip around your ratio, not your angle. So we just need to know what a secant is equivalent to. Well, secant is when you flip a cosine. So cosine is adjacent over hypotenuse. So now it'll be a hypotenuse over adjacent. By the way, that's a negative 1. It didn't matter. All right, this one we can check. It's a bit trickier. You can't actually type in secant. So what you can type in is cosine of 11 pi over 6. And then put a little negative 1 after it. That'll flip it for you. But if you're like me, I make sure you go back to radians now. That'll give you an answer. And if you do 2 divided by root 3, here's hoping it's the same answer.
Why do you go back to radians?
Because 11 pi over 6 is, hopefully that's clearly a radian type measure, as opposed to 300.
You have to do it because it has the
Degree symbol, yeah. Yeah.
Okay, so I get that in, and I didn't get that.
Fair enough. Let's see, radians versus degrees. Yeah, here are degrees. So go to radians. Do it again.
Oh, God.
Okay, one more thing I should show you guys here, just to be thorough. There's a chance, actually I think it's a pretty strong chance, that if this was multiple choice, the diploma would not give this as the answer. They would actually do this as the answer. Does anybody know how in the world I made this turn into this one? Yeah, it's called rationalizing. It's a skill we worked on a little bit last year. If you have 2 over root 3, mathematicians have, by some arbitrary rule, kind of said that simplifying things means there's no more square roots on the bottom of fractions. There's no actual real reason behind that I know of. It's just that's the rule.
Please excuse the interruption. Can the following students please come to the office? Michelle Barnes, Leland Bastine, Carson Blackwater, Olivia Bond, Braden Boot, Grace Boland, and Bethany Brobble. Can you please come to the office?
Did what I did there just make sense? So 2 over root 3, I just times by root 3 over root 3. Because what happens is the root 3's in the bottom literally turn into the number 3. And now you just have the square root on the top instead. So both of these are equivalent to each other. Well, I guess those are equivalent to each other too. But chances are I think they'd write it like this. Should give you the same number though. How's that work so far? Okay? Okay. Second possibility. If you are asked to solve where sine of theta equals a number, this is where there's going to be an infinite number of answers. Not just 2 answers. Technically, there's multiple answers. So many answers we can't even solve for. I showed you this one earlier. Here's a graph of sine of theta. Here's where it would equal 0.5. It's going to cross that graph millions, like infinite times. Does that make sense? So what we often do is one of two things. We either give you like a parameter and we say, find all the angles between 0 and 2 pi. That's one of the things you might get asked for. Or the other possibility is they ask you for a general solution. Does that make sense? That second last bullet down the bottom there, you may need to rearrange the equation first. You guys have done this before. I threw a few of these on your last assignment. If I told you that you had 2 sine theta plus 1 equals 0, this is something that you could rearrange, because you'd make you'd minus 1 from both sides, you'd divide by 2, and I'd ask you where sine of theta equals negative 1/2. You guys recall doing that? Okay, so let's try a few of these then. Let's just do one of them first when we've got a coordinate point, because we could do that. Let's just do the second one. That looks more fun. So for the second one, negative 12, negative 5, go way back and way down, somewhere like this. Negative 12, negative 5. Estimate the angle in degrees. The angle is all the way around to there. Does that make sense? Come on in. Is it locked? So it's somewhere over 180, but less than 270. I think so. Is it locked? Oh, sorry.
It's okay.
I thought it was unlocked. They had cheat, guys. Cheat strings.
Oh, yeah, black.
Thank you. Do me a favor, would you close the door as well? Thank you. This is going to be like, 200 something degrees. So as a way of solving this, what you could do is you could tan inverse opposite over adjacent. Does that make sense what I just did there? You could almost write it like this. The tan of theta would be the opposite over the adjacent. So if you inverse tan this thing, you're going to get an answer. I say that a lot because the answer you get might not be the right answer. We have to then use our judgment after that to help solve this. So I'm going to do this in degrees just to help kind of make it a little more sense right now. So make sure you're in degrees when you do this. If I inverse tan, 5 over 12 basically, my calculator gives me 22.6 degrees. Is that the answer? No. Your calculator will find the closest answer it can, because remember, there are an infinite number of answers that could work. And your calculator just found one of them. Well, unless I just made a positive 5 over 12. You get the same answer, right? So the 22.61 degrees then would be as though it found an angle in this quadrant right here, which would have been 5 and 12. Kind of like Devin just kind of pointed out there, right? According to the cast rule, you should be able to get a positive in this and in this quadrant here. So your calculator found this one as 22 degrees, basically. Well, that means that this right here is 22 degrees. So when you add 180 to it, it should be 180 plus 22.6, so 202.6 degrees. Does that make sense? The point I want to make on a question like this is just make sure you don't just trust your calculator and just be like, hey, my calculator gave me the answer. No. Your calculator gave you an answer. And that's one of the biggest problems with Trig, is that there's a million answers. It just picked one. I think it regresses to the closest one to 0. So, does that work? Okay, so let's move on then. Like I said, if you guys are feeling like you've got this, maybe do the opposite. If you guys need more examples, let me know. Does that work?
Can we do one more like this?
You want to do the other one then?
Yeah.
Sure, let's do one more. Let's do the 4, negative 3 then. So if it was supposed to be 4, -3, that would be down here. 4, -3. Anybody know what the other side would be?
5.
It would be 5, yeah. 3, 4, 5 is one of the types of triangles you could have. Estimate the angle in degrees. Anybody?
Like 330 maybe?
Good. I was hoping you'd start with 300 something. I didn't want you to say 50 or 60 or something like that. Although this right here might be, I don't know, 45, 50, whatever it happens to be. We're caring about that angle there. So make sure that you don't forget that we're looking for the large angle. So at this point, we just need to figure out what we want to inverse. We need to inverse either sine, cosine, or tan. We could actually do all three if we wanted to. I'm going to recommend tan. Let's inverse tan, the opposite, over the adjacent, and see what it gets us. Inverse tan, the opposite over the adjacent. It gives us -36 degrees. -37, I guess. Is that the answer we're looking for? Probably not. What we actually would like is the angle all the rest of the way around the circle. -37 degrees just means it went backwards to find its first answer. That's fine. So, I don't know, if I combine that with 360, then it's 323 degrees, it looks like, the rest of the way around the circle. Does that make sense? Let's hop to like one of these ones on this page here. Let's do C first. I think that's probably the one where most worth our time here. We'll do this one. Okay, so one of the things you got to pay really close attention to then, does it ask you to find the answers between 0 and 2 pi, or does it ask for a general solution? And this one here says solve for everything between 0 and 2 pi. So chances are there's going to be, like, say, 2 answers. There might even be more than 2, though, depending on how this looks. So first question, how do I solve this when we have to, like, rearrange stuff? Any thoughts? Bring the 1 to the other side. Divide by 4. What you're going to get then is that sine squared theta, it's like x squared basically, is equal to 1/4. And then how do you get rid of a square symbol? I should point something out, by the way. You know when you do like sine of theta and you want it all to be squared? As a way of making sure that we're really clear that it's the sine symbol, like all of it's being squared, the notation we use is we write the little squared sign right in that location there. The reason why we do that is because otherwise you might think that it's sine of your angle squared. And to be honest, I can actually think of very little reason as to why you'd actually want to square an angle, right? Because like your angle could be 5 degrees. Well, if you square your angle to get 5 degrees, now it's 25 degrees. That's not what this is asking, though. This is asking once you find the ratio, then square that. So, long story short, you do need to square root. What happens now is you get sine of theta. 1 can actually square root to give 1. And 4 actually can square root to give 2. There's only one problem. This is not it. When you square root, there's always a plus and a minus square root. And so it also could equal -1/2 as well, because square roots are pluses and negatives. I then myself would just draw a little diagram here and say, well, where is sine supposed to be positive? Sine was supposed to be positive in this quadrant and in this quadrant. So normally I'd suggest you should have 2 answers. However, because it also could be negative, you could have angles in the lower quadrants as well. So I'm expecting 4 answers. Does that work? All right, now plot some stuff. All your hypotenuses, hypoteni? What's the plural of hypotenuse? Anyways, all of your longest sides are 2. And your opposites are all 1s, except a couple of them are -1s. So that makes the other sides √3s. So I just got to figure out what angle goes in here. Is it a 30 or a 60? $30 degrees goes in this corner right here?
Yes.
As long as you have your way of memorizing it.
Please excuse the interruption. Can the following students please come to the office? Jaden Brown, Haley Servo, Jay Cotton, Brendan Curlyrider, Bailey Davis, Zion Davis, Kathy Delver, and Justin Draper. Please come to the office.
Would it be okay to say then that that angle is pi over 6 if it's 30 degrees? All right, so here's my answers then. This one right here would be pi over 6. This one in this quadrant right here, if you can imagine that it's been broken up into sixths of pi, it's 1/6 less than full. So 5/6 of pi, or 5 pi over 6, yeah. The next one is 1 pi over 6 more than full, so that would be 7/6 of pi. And then the last one will be almost full and all the way up to 12/6, which would be 11/6 of pi. You'd have 4 answers then. I guess. Does that make sense? All right, let's move on then, if you've got the hang of this. General solution. Let's do C for this one right here. Is this sufficient, by the way? Like you guys are, we don't need to do every example? Okay. Let's do the secant cubed one. That one's kind of challenging. How do you get secant by itself? You gotta cube root everything. Okay. The good news is that -8 does cube root. So if you cube root everything here, you'll have regular old secant theta. And if you cube root -8, it is -2. Square roots will give you double answers because you can have a plus or minus square root. Cube roots, though, that's not the same way, though. So, any ideas what we do here? Would it be fair for me to say that this is like 2 over 1? Okay, well, if secant is equal to 2 over 1, then cosine of theta is 1 over 2. That is the appropriate time to kind of flip it upside down. But you don't flip the angle upside down, you flip the ratio upside down. And now we're at a point where hopefully you remember how to solve this. So draw a little grid. Where is cosine negative? CAST here and here. Hypotenuse is 2, adjacent is -1, that side has to be √3. This is 60 degrees right here. So that makes it pi over 3. That's also pi over 3. So all the way around to here then would be 2/3 of pi. All the way around to here would be 4/3 of pi. There's our answers. That's not right though. I said a general solution. General solutions aren't probably the hardest thing to deal with. It's just you need to recognize that you could keep going around a circle over and over and over again. So you just got to figure out how long is it until it goes around a circle. Cosine graph, what's the period of a cosine graph? 2 pi, yeah, like a full circle basically, right? So the better way of writing this is it'll be 2/3 pi plus or minus 2 pi n. You guys remember writing that sort of notation? And you'd also have 4/3 of pi plus or minus 2 pi n. Basically, this is just notation referring to the fact that you can go around the circle multiple times in either the positive or negative direction. Go ahead. This right here is probably the best way of phrasing it. There's an answer at 2/3 of pi, but you could go around the circle either forward or backwards and any number of times. There's also an answer at 4/3 of pi, and you could do that any number of times as well. Still doing okay? Let's do B on this one right here. Sine of 2 pi. This 2 right here inside the fraction throws something off a little bit. it makes it so that you you can't divide that 2 away, unfortunately. You can divide the first 2, like the 2 out front, you can divide both sides by 2. And it gives you sine of 2 theta equals negative 1/2. But this 2 sitting right here, you cannot do anything with. So what ends up happening is you're going to deal with that 2 later. Okay. There was a question on your assignment like this that was like a tan of 3 theta. It just means you divide everything by 3 at the end, not now. So, again, plot some triangles, cast rule. Where is sine going to be negative? Down here. Down here. Isn't it? It's either 30 or 60, one of the 2. Yeah, it should be 30, isn't it?
Isn't there a rule where it's like smallest side bases smallest side?
That'll work. That's clever. So since this side right here is the negative 1, you make that the smaller end? That's really clever. I've never actually thought of that before. I always just tried to memorize one way or the other. That's clever. Alright, so that makes that pi over 6. This is also pi over 6. So your answers are going to be 7/6 of pi and 11/6 of pi. That logic makes sense. I didn't explain it, but... Okay, I'm going to deal with the going around part in a second, though. We're not to that step here, because this is what 2 theta equals. So before I keep going here, I should really deal with that 2 theta problem. And the easiest way of doing that is we just need to divide everything by 2. So my answers for theta, I'm just going upwards here, are you actually have 7/12 of pi and 11/12 of pi. Does that make sense? That 2 takes your graph and squishes everything in. And so all your answers will be half as much as they used to be. And that's basically what we did. This answer here is now half as much as it used to be. Yes?
That changed the period though.
It does though, yeah. That's the reason why I wanted to show this one. Normally the graph happens every 2 pi. Now the graph is going to happen every 1 pi. So you know how you have to write that like plus or minus 2 pi n? You're not writing 2 pi n. It happens every pi n instead. That's the reason why I wanted to point out this question here, is that you don't have to go all the way around a circle anymore. I mean, technically you do have to go all the way around a circle, but a circle doesn't happen in 2 pi. Because you've squished everything in, a circle happens in pi instead. Any questions? Okay, why don't we skip ahead to some of those diploma questions then? Oh, actually, you know what? I should do one of these solving by graphing ones. Let's just pick this stupid dumb one at the end here. Let's solve D. Let's say they ask you to solve this guy right here. I don't really have a great way of getting a sine or cosine by itself to try to solve. Like, for example, in this one up here, I could subtract the root 12. I could divide by 4. I could try to make some magic happen. But there is another way of solving. You can always use your graphing calculator. So what you could do is take your graphing calculator and type in sine x cosine x plus sine x plus cosine x. I have no idea what that graph's going to look like. I don't care. That's not relevant. And then in y1, y2, I'll make it equal to 1. Or maybe I'll do -1 and do it properly. Does this make sense what I'm suggesting here? I mean, if you can't solve something algebraically, you can probably solve it using a graphing calculator. Just make sure you use an appropriate window size. If I'm in degrees, which I think my calculator is, don't go from 0 to 2 pi. Go from 0 to, say, 360. And then you know how my y scale, at least on my graph right now, is going up by 1.57? I might recommend make your y scale go up by 90s. Just because like 90 degrees is like a decent section size. And then now I'll graph this thing. So, I have no idea what the first graph's going to look like. So there's 90, that's 180, 270, 360. It's a fun graph. It's got to cross somewhere in here, I imagine, right? So just use your intersect function to solve that. I'm just going to take a leap of faith and just... Okay, there we go, 180. If I were to zoom in here, I don't know if this graph kind of like loops up and down a little bit. So I'm just going to try moving it over more and see if there's another intersection point in there somewhere, because there might be. So I'm just going to move the cursor more. I don't know. Let's go about there. Okay. Anybody else's calculator freezing on them?
I got 90.
Oh, finally worked. I got a 270. Anybody else get 270? Eventually?
90, which is reciprocal 270.
You got 90.
Yeah, negative 90.
Oh, because your calculator went back to the previous one. That works too. So, yeah, because I guess negative 90 would be the next one, probably way over here. Anyway, does that make sense of this skill you also can use? If you're absolutely stumped trying to solve it algebraically, just use your graphic calculator. I can't guarantee it'll work in every instance, but I mean, it's a good tool to have. Okay, let's try some of those diploma questions now. That's really, I think, where we're up to. So let's try... Actually, you know what? Why don't you guys take a break? And then we'll pick like maybe the first 4 or so, and then I'll let you guys do the rest later. But take a break right now. It's been a while. Okay. I was thinking while you guys were gone, trigonometry, I don't know whether you guys have the same opinion as me, but it's actually kind of easy in a way. There's really only 2 possibilities.
Levi Draper, Shantea English, River Featherstone, and Brady Ann Feller. Please come to the office.
Either you have to solve for an angle, which means that there are many possible answers, and so long as you understand how the circle kind of concept works, you're good to go. Or if you're given an angle, you have to solve for a ratio, which means there's just one answer. You know, like it sounds so simple on the surface. And I think that's one of the reasons why it's the worst on the diploma exam, because the types of questions you're going to be asked to solve now aren't going to be that straightforward. And they ask them in such weird and awkward and foreign sort of concepts that students often struggle the most on trig, even though they might, if you're like me, you look at it and go, well, that's all we've learned. Because honestly, this is like almost all of the trig curriculum right here. And I feel like you guys were looking at this going, I got this. Or at least you feel pretty comfortable.
It's not like the Alberta government want us to do well. Like, why would they make it hard? It doesn't make any sense.
I agree. I totally agree. Like, they really try to make it challenging to pull grades and spread them out more. One of my thoughts was, I mean, I almost kind of prefer than on the diploma. I'd rather be asked to like synthetically divide something, do something that's very like long and time consuming, because a very process based skill like that, I mean, so long as I don't make a mistake, even though it's going to take me a minute to do some synthetic division, I'd almost rather have that question because it's very straightforward. Does that make sense? So one of my goals in trigonometry then is I want to show you as much variety of trig questions as I can so that you kind of get used to what you might be asked to solve. Because most of the battle, I would say, in trig is not in using the trig skills. There's not even a lot of work to show in trigonometry, really. Most of it, I think, is going to be interpretation. If you can understand what you're being asked, then you'll probably be fine in trig. But that's your challenge. Does that work? So let's not go through all of these. Let's do, like, say, 4 of them, and then you guys can have the rest of class to study for your test. And then tomorrow we have a work day. We'll do the rest of them tomorrow. But let's just do a few while we're still thinking about this. So let me walk you through my thought process then as I interpret a question. Okay. It says there's a line, y equals 1/2, intersecting a graph. Intersect. I have no idea what this graph looks like. But I can kind of imagine that what they're looking for here is there's some sort of sine or cosine graph that looks like this. And where it equals 1/2 is where all of the solutions would be. That's kind of what I'm seeing in my head. Does that make sense? What they're saying here is, what is another equation that can be used to solve for x? Well, if I were to try to write this out, it would kind of be like cosine squared theta minus sine x. That's supposed to equal 1/2. Does that make sense how I'm kind of making this equation and this equation like equal to each other? Unfortunately, that's not one of the 4 answers. And this is often a big frustration in the trig unit, is that you'll get an answer, and it's totally valid. It's just not one of the 4 choices you have. And so now you have to manipulate and mess with things until you can make it one of the 4 answers. So as I look at them, I don't think the first one is anything I can achieve, because I need a 1/2 there somehow, and that's not really happening. B and D look really similar. I think what's happened on B and D is they've made it equal to 0. So in order to make it equal to 0, they must have minus the 1/2 to the other side, which makes it a cosine squared x minus sine x minus 1/2.
Daylene Dietrich, please come to the office. Daylene, to the office for checkout, please.
At 9:30. Yeah, I think that's the other thing they've done is they've times everything by 2. So you could times the 2 up, I guess, first, or what you could do right here is you could times this by 2, times this by 2, times this by 2, and when you times 0 by 2, it stays 0. So however you want to interpret that, either times this 2 over here and basically double these terms right here and then subtract the 1 over. But now I believe we have one of the 4 answers. It's B. Does that make sense? The thought process I want to talk you through there then is when you struggle and you sometimes get to a point you're like, I don't know what to do. Sometimes you just have to play a little bit and see how you can kind of algebraically kind of rechange a few things around to get one of the 4 answers they give. Because that's what they're going to try to do to make it more challenging. Let's try another one here. There is a lot of information compacted into this sentence that you're given here. And so let me walk you through my first thought process. It tells you that cotan of theta is equal to negative 3 over 4. Based purely on that, I can now start to plot what that means. What is cotan related to? Tan. Okay, so I could rewrite this then as tan of theta, and then if I flip it, it would be negative 4 over 3. And according to my Cast law, I should be able to then kind of write out where this should be negative, because tan is going to be negative in this quadrant and in this quadrant. I'm going to plot some stuff. In this quadrant here, it would be opposite over adjacent. In this quadrant here,
Alex Garrett, Madison Orr, Taven and Tanea Goodstriker, please come to the office.
they're checking that after an hour or 2. I know. Oh, yeah, maybe it's like a...
I remember getting them in grade 9.
That makes sense. Does it make sense to you guys that there's 5s on the hypotenuse? This is hypotenuse. Hypotenuse. I don't know. So do you remember that there's like the 3, 4, 5 triangle?
Yes, I know.
Okay. Okay. So based purely on just the first statement right here, cotan equals that, I've now drawn this out. Then as I keep reading, it tells you that cosecant theta is less than 0. What is cosecant related to? Sine. In a way, what this means then is sine of theta is also less than 0. This really means that sine is a negative number. Should I say that one more time here? Cosecant is related to sine. And if it's less than 0 means it's negative. So this has now told me that we're looking for a negative value for sine. Which quadrants could sine be negative in? Technically 3 and 4. That being said, do we actually have a triangle in quadrant 3? But we do have a triangle in quadrant 4. So as a way of looking at this, I could kind of cancel these guys out and say sine is not negative there. This information here has helped narrow down which quadrant to look in. Last question then, it says, what is sine of theta actually equal to? Well, sine of theta is whatever your opposite and hypotenuse are. The opposite's the negative 4. And the hypotenuse is a 5. So the answer is A. There's a lot of info in that question kind of hidden in each of these little statements right here. Because I feel like we've talked about those skills there a lot over the last 2 weeks, right? It's just, can you interpret what the heck it's asking? That's the challenge. Does that work? Okay, let's do 2 more and then we'll call it quits. So as I read through this question statement by statement, first it tells me that cosine of A is root 3 over 2. My first thought as I read that is that root 3 over 2, those are like special triangle numbers, right? So I'm going to plot out where that is. According to the Cast law, you could have a triangle here or you could have a triangle here with the adjacent and the hypotenuse. Like that. The next thing I read, though, helps narrow this down immediately. It says that my theta, though, is between 0 and 90. So what does that help me figure out? Yeah, it's just in the first quadrant. So all I need is whatever this angle here is. I'm not looking for that one. What angle would that be then? 30 degrees, yeah. And based on the fact that it gives me degrees right here, I should go with 30 degrees rather than pi over 6. So I now know that my theta is 30 degrees. Or I guess like A is 30 degrees. That's my angle there. The next statement then says that B is 60 plus A. So 60 and 30 means that B is equal to 90. Does that make sense? And then it wants what is secant of B. So then it says what is the secant of 90 degrees. That's ultimately what the question is. So we could then grab our calculators. And can you actually type in secant? But you can type in cosine of 90 and then reciprocalize it. I'm making up verbs here. Yeah, because what ends up happening is cosine of 90, it's like 1 over the cosine of 90. But cosine of 90, if you remember your cosine graphs, at 90 degrees on a cosine graph, it's at 0. So what you just asked your calculator to do is go 1 over 0, which it can't do. So that's why it's undefined. Does that logic make sense? Again, all little skills that I feel like you guys probably possess individually. The bigger question is, can you interpret this and just put them all together? All right, let's do one last one, then we'll call her a day. So it gives you some pictures to look at. It tells you that one of the graphs is cosine, which I'm guessing, I'm just going to color coordinate it. That's probably this one right here. This is the cosine graph. And then the next one is cosine 2x. I'm going to put that one in purple. The 2 just means that the graph's been squished in. So hopefully you can see how there's, rather than this happening once, it's now happening twice because like a accordion, it's been squished inwards. So then it says the graph was supposed to intersect 4 times between 0 and 2 pi. I'm just going to try to find where those 4 times the graph crosses. Here's clearly 1. Here's 2. Where's the other ones? Right at the start and right at the finish, it looks like there's the 4 times. Does that work? Now I haven't even read the question yet. So as I read the question, then it says if the domain is changed again from 0 to 2 pi, but do you see the little sentence they said here? The equality has been removed. So rather than getting to count 0 and getting to count 2 pi, what do you think happens with these 2 things right here? We can't count them anymore. So then there would be fewer solutions. Huge variety of questions, right? In terms of the skills we've learned, I'll say this a lot, there's only a few skills you need to know in Trig. They're fairly straightforward. It's just can you use them to solve questions. Give me one last thought, then I'll shut up for the day. I'm just going to find you that curriculum again. I've done this before. Here are the outcomes that I'm supposed to teach you guys in trigonometry. Again, they're fairly broad, but let me know if you have any issues with this. Do you understand how angles fit in standard position in either degrees or radians? Basically, can you plot a circle and figure out how angles work? And are you good with both the radians and degrees measurements? Do you understand how a unit circle works? Sometimes our unit circle is not a unit circle, like it might be a 3, 4, 5. You just have to divide by whatever the radius is to make a unit circle. Do you know how to solve problems? Basically. Again, in radians and degrees. 4, do you know what the graphs look like for sine, cosine, and tan? 5 I should talk a bit more about. 5 is, can you solve either using algebra or your graphing calculator first and second degree trig equations? Do you guys know what second degree trig equations would be? Clever. No. This one right here is a second degree trig equation, whereas this one right here is a first degree trig equation.
Oh, okay.
Why?
There's like
That makes it a second degree.
I thought it meant because there was like.
No. So the only reason why they're saying second degree then is because it could involve something that is squared, which just means to solve it, you square root it. That's all. So yeah, can you solve basically trig equations? And then the last outcome, which we haven't covered yet, this is the Thursday, Friday, is basically about something called proving trig identities. And that's what we'll do later. So, does that make sense? Okay, let's call it a day. You guys can work on whatever you need to for the next little bit. I'm guessing studying for social. We'll talk more tomorrow.